Hi and welcome to this solution video of paper 12 additional math Igcse Cambridge International Exams. And if you like this video, share it with your friends and subscribe to Math United. I'll be preparing many more videos on this topic in coming days. Let's start with question number 1. The diagram shows the graph of a cubic polynomial. This one. A part says find the expression for fx. That means write the function's equation in factored form. Write each linear factor with its coefficient as integer. What it means? Let me give you an example what they're trying to say. They're saying this. If this comes out to be x minus half, don't write this. Write it as 2x minus 1. This is what they're saying. Okay? So I'll try to do that way. Okay, so first we know this is starting from here and ending here. So in second quadrant it is starting. That means its coefficient, main coefficient will be negative. That's why it is not normal cubic function, because normal cubic function is like this, but it is starting from here. That means it has been reflected, and that's why it will be having a negative a, and which will be proven very soon. Okay, so first let's write what could be the equation of fx. It can be fx equal to a, and then we have x plus rather let me not write plus, let me show you that minus 1/3. This is what we write. Each factor is subtracted from x. That's how we write it. Second factor will be the second x-intercept, which is 1, and third is 5/2. Okay, so can I write this like as this: a 3x plus 1/3. Pause the video and see if it makes some sense. Okay, then this will be x minus 1, and this will be the same thing, 2x minus 5/2. Again, try to understand this one. Okay, so once you understood why I did this, because if I open this up, I'll get again x plus 1/3 and x minus 5/2 if I separate with this 2. Now this a is the problem. We don't know what is this a. So what will I do? I will substitute some let me write y here. Okay, in place of fx I'm writing y. So let me choose a point which is not out of these 3 points. Some fourth point is needed, and that fourth point is this. Negative 15 is the y-intercept. So it is 0 minus 15. This is what I'm going to substitute here. So y is minus 15 equal to a 3 times 0 plus 1/3. 0 minus 1, 2 times 0 minus 5/2. So what do I get here? Minus 15 equal to a. This is gone. So a 1/3 minus 1, and this is also gone. So minus 5/2. So a is the only one remaining here. So let's cross multiply everything and we'll get the value of a. Let me do it here. So this 3 and this 2 will multiply with minus 15. That's what happens in cross multiplication, right? The denominator is on one side, we multiply with the numerator on the other side without changing the sign. Then there we have 1 here, minus 1 here, and minus 5 here. So minus 1 and minus 5 I can write here. Minus 1 and minus 5 I can write as denominator of the other side. This one there is no need. Why I wrote minus 1? I wanted to carry this negative also. So we have 3 negatives. Whenever we have odd number of negatives, the simplification is negative. Okay, when you have even, simplification is positive. So we have 3 negatives, it becomes negative. Okay, 15, let's cancel 5 and 15 now. 3 times 3 is 9 times 2 is 18. So we got a equal to negative 18, and rightly so, I told you already that a should be negative because it is reflected of the normal cubic function. So now let me write the equation which was this one, right? Rather this one I can do. Okay, y, in place of y I will write fx equal to negative 18 and 3x plus 1 I'm writing here. This 3 which was denominator here I will write here down 3. Then we have x minus 1 and then we have 2x minus 5. Let me make more space and write here 2x minus 5, and this denominator 2 will be written here. So what do we get finally? Finally, because this 18 and 3 and 2 will cancel out. 3 times 2 is 6, times 3 is 18. So minus 3, 3x plus 1, x minus 1, 2x minus 5 is the final equation of this cubic function. Okay, let's go to question number B part rather. Write down the values of x such that fx is less than 0. It's not 10, it's less than 0. Misprinting. Okay, fx is less than 0, so let's see where is fx is less than 0. That means this y is fx. We want it to be negative. Less than 0 means negative. It is negative from negative 1/3 to 1, right? This whole part, the y portion is negative. Also greater than 5/2, this one also fx is less than 0. So I will write between minus 1/3 and 1 and more than 5/2. That's the answer. So minus 1/3 and 1, between them it's negative, not equal to, right? On these values it is 0, so we can't write equal to. We want only negative. There is no equal sign here. And second answer will be x is greater than 5/2. These are the two places where the fx is negative. Question number 2 is here. Function g is defined as 5 sine 3x/4, that is the angle, minus 2 for all values of x. Write down the amplitude of g. So if you remember, this is the common format. The alphabets may be different, but this is the common format of any trigonometric function. A, in this case let's write sine bx plus c, where a becomes the amplitude. Whatever is the coefficient of sine or cos becomes the amplitude. What is the coefficient of sine in this case? 5. So write down the amplitude of g. Amplitude is equal to 5. Write down the period of the g in degrees. Period is always 360 divided by coefficient of x in angle. So b, basically 360 divided by b, which is coefficient of x. So in this, what is this angle? If you look carefully, it is 3x/4, which we can write as 3/4x. So what is the coefficient of x? 3/4. So our period will be 360 divided by 3/4. Okay, and whenever we want to convert a division into multiplication, it becomes the reciprocal of the denominator will be multiplying, not dividing this time. So we can say that this is 120 times 4, 480 degrees is the period of this particular function. On the axis, sketch the graph of y equal to gx from minus 180 till 180, and this is equal sign also. So let me draw axis. So now our job is to complete a graph, one cycle of graph in 480 starting from 0, and we'll start from axis. And 240 is somewhere here where it will again meet axis here. So let me try to draw the graph. Meets here, reaches minimum somewhere and reaches axis again. Not here, huh? Axis, its own axis. But they asked us to draw up to 180 only. That means it was just a support. We will erase after 180. And this is erased. Now, what about the negative? Will be a reflection, something like this, not reflection, but continuation of this graph. And again, before 180, it turned. So before this minus 180, it will turn. So it is something like this will be the graph from minus 180 degrees to 180 degrees, and we have done it. Natural log of y plus 2 is plotted against x square. A straight line graph is obtained. So let's visualize this. This is natural log y plus 2. Natural log y plus 2 is plotted against x square. Since our axes are labeled strangely, so to make it simple, what we can do, that the capital Y is natural log of y plus 2 and x square is capital X. So basically this becomes our y, capital Y axis, and this becomes our capital X axis. Ignore x square and len y plus 2 for the time being. Okay, so I'm not cancelling them, but I'm ignoring them. So my equation now will be between y and x capitals, these ones. The line passes through 2.25 and 9.37. So let's say 2.25 is here, 9.37 is here. It's just random, okay? I'm not going according to the scale. I'm just visualizing it. 9.37. Okay, and 4.7, 3.92. 4.7 will be more and 3.92 will be lesser. So 4.75, 3.92. And now we will join these two with a line. So let me join. Okay, joined. Okay, this is the line. Find y in terms of x. So how about finding the equation of this line first, and then we can talk about y and x. Okay, so what will we do? We will find the equation in terms of capital Y and capital X, which will be capital Y equal to m capital X plus c, where c is the y-intercept, this one. Okay, so we'll first find what is m, gradient of this straight line, which is y2 minus y1 over x2 x1. Okay, so y2 is, let's say this is y2, 9.37. We can take anyone as anyone, but I'm thinking that this is y2 and this will be y1, 3.92. Okay, divide by x2, which is 2.25 minus 4.75. Use your calculator to find this. I'm trying this mentally. So 37 plus 8, 45, and it will be 5.45. Okay, then we have this one minus 2.5. Okay, minus 2.5, which comes out to be equal to 2.18. So we got our gradient. Now job is to find C. So to find C, we will substitute any one of the points. Let me substitute this smaller number of points here. Here the y is 3.92, capital Y, that is 3.92, equal to, next we have m, we got it 2.18. Then x is 4.75 in this point, plus c should be negative 2.18, negative 2.18, right? So now c will be, this negative will become positive here, so 3.92 plus 2.18 times 4.75. Okay, let me use my calculator to find this out. By the time I do this, I would request you to like this video, share with your friends, and subscribe to Math United. What I'm getting here is 14.275. Okay, got C. So now I can write the final equation, which is capital Y is equal to negative 2.18 x, not x, it will be capital X. I'll have to change it. Okay, capital X plus 14.275. Makes sense? 14.275. If it goes there, it may be 14. This because we already have 9 here, so this can be 14.275. Makes sense. Okay, but that was not our question. Our question was find small y in terms of x. Now what will we do? We will substitute y by its original value given in the question, which is ln y plus 2. Equal to negative 2.18 x replaced by its original value, which was x square plus 14.275. We have to isolate this y because we want y in terms of x. That means this y must be isolated. For that, this natural log has to go first. So when natural log goes, the other side becomes the power of e. So it will be minus 2.18 x square plus 14.275. Y equal to, I need to isolate this 2 will go and subtract from this, and meanwhile, because these are adding, let me write e to power 14.275 alone, and then e to the power minus 2.18 x square separate. Okay, and then we got this 2, which will be minus 2. So let me see what is e to the power 14.275. Okay, it comes out to be, oh, big number, 1583. Okay, y equal to 153265. E to the power minus 2.18 x square and minus 2. That is y in terms of x. Okay. In question number 4, A part, it is given that the first 4 terms in an ascending order power of x in the expansion of this 1 minus x over 2 to the power n, okay, are this 1, this is px square, this is qx cube, where n, p, q are integers. Find the values of n, p, q. Okay, so they're saying first 4 terms. So what will be the first term? Let's expand this. When we write first term, we start with nc0 and give the first term as a power 0. However, since this is increasing, ascending powers of x, will give that power 0 to x over 2, rather minus x over 2. Okay. Why? Because we want ascending powers of x, not 1. 1 will be given the rest of them, which is n. Second, nc1 minus x over 2 to the power 1. So this number and this number must match. What is left for 1? N minus 1 plus nc2 minus x over 2 to the power 2 and 1 to the power n minus 2. 1, 2 and 3, and then the second fourth also. So fourth, nc3 minus x over 2 to the power 3, 1 to the power n minus 3. One thing we should first take care of is that 1 to the power anything is 1. So this is of no significance. We can ignore 1 to the power anything, right? So just let's see if this thing matches with each one of them. So this one should be 1, this one should be minus 8x, this one should be plus px square, and this one should be qx cube. Let's see. NC0 is 1, so let me write 1. Anything to the power 0 is 1, and anything to the power 1 is 1. So 1 is equal to 1, that's fine. The first term gave us nothing. Let's talk about the second one. NC1. Anything C1 is that number which is the main number, which is n in this case. Okay, minus x to the power 2. So let me write minus half x. Yeah, I'm breaking it so that I can compare it with minus 8. So minus 1 over 2x, and this is again 1. This is equal to minus 8x. So x is in both sides, we can cancel them out, we'll find n from this. So it was n, and what did minus go? Okay, since n and these are multiplying, I should not have written this minus outside, it is inside minus. Okay, so we get minus 1 over 2n equal to minus 8. So n comes out to be minus 8 multiplied by 2 divided by minus 1. This minus 1 comes down. So they cancel out. 8 times 2, 16 is the n. Okay, let's go for P and Q. So second, now we know n, so we can use 16 now. So this one, this is already done. This will give us the next one. N C2 will be 16 C2, which is 120. Then 120 multiplied by minus will make this square will make this minus positive, because minus times minus is positive, so it will be just x square over 4, and that is px square. Again, we can cancel x square from both sides, and 4 can cancel with 120, so p becomes 30. We got already n, we got p, and the last one will be q. NC3, which will be 16C3, is 560. So 560 multiplied by minus will remain minus because of q, it's an odd exponent, so minus remains minus, so times minus 1 over 8. Let's write x cube over 8. Yeah, 2 cube is 8, x cube is x cube, and that is qx cube. So x cube can cancel from both sides, and this was multiplying, right? Yeah, so this 8 can cancel with this, which is 70. So negative 70. Q comes out to be negative 70. We got all of them. Next, find the term independent of x in the expansion of this. That means it has nothing to do with a part. We have to start afresh in this one. So the term independent of x means x to the power 0. So we can see here, let me write this one properly, 2 over x square plus x over 3 to the power 6. We have to select x such that if I apply the expansion like previous part I did, if this one, this NC, this kind of expansion, if I do, I get 0. So let me do it here. 6C something, here I write something, over, I'm not looking at 2 and this 3 because they have no role in x. So I will write 1 over x square. To power that something, whatever something I write here, that something here over x. I'm not writing 3 also. Alright. What exponent should I give it to 2 so that it cancels this one? So that means this exponent should be half of whatever exponent I give, and their sum should be 6. So obviously this comes out to be 2, this comes out to be 4. Isn't it? Because 2 plus 4 is 6. And if 2 is squared, it becomes x to the power 4 at bottom. If x is given 4 powers, it becomes x to the power 4 on top, and they cancel out. That's how I will get 0 independent of x term. So that's what I'm going to do now. Here I've got my answer. So 6c2. Now I'll write the proper one, 2 over x square to the power 2. And then we have x over 3 to the power 4. Okay. Now 6c2 will be 15. Let me confirm. Yes, it is 15. So 15 multiplied by 2 square is 4. X square will be x to the power 4. That was the plan. X to the power 4 is x to the power 4, and that's why they are equal and they cancel out. 3 to the power 4 is 81. So this goes cancels. So what do we get here? 60 over 81 is the term which does not have an x. It is independent of x. Can I somehow minimize this? Yes. So 20 over 27. That's the answer. Let's see what next question has for us. Okay, the question says solve this equation, which is a trig equation, and give your answer in terms of pi. Okay. So the question says solve this one. So let me rewrite the equation first. 3 secant square 2 theta plus pi by 6 equal to 4, and we have to solve it. Okay. Can I do this way? Let's bring this 4 here and secant square to the other side. So it becomes 3 over 4 on this side and 1 over secant square 2 theta plus pi by 6 on the other side. Now secant is a reciprocal of cos, so I can write 3 over 4 equal to cos square 2 theta plus pi by 6. Okay. Now if I square root both sides, I'll get rid of the square here, and if I square root here, I have to write plus and minus. Both will be the square roots of 3 over 4. Alright. So my first, let me write here, first possibility becomes cos 2 theta plus pi by 6 is equal to square root 3 over 4. Let me write square root 3 over 2 because 4 has a square root, right? So square root 3 over 2, and second one cos 2 theta plus pi by 6 equal to negative square root 3 over 2. Since our quadrants are from minus pi by 2 to pi by 2, let me show those quadrants to you. This is 0, this is minus pi by 2 in clockwise direction, and this is pi by 2, positive pi by 2 in counterclockwise direction. Okay. So my answer in this will be the positive one. Yeah, because cos is positive here. So this will be the angle 2 theta plus pi by 6. Okay. So 2 theta plus pi by 6 is equal to cos inverse square root 3 over 2. No other quadrant we have to look at, just look at this one. What angle gives you square root 3 over 2? That is 30 degrees, but this is in terms of pi, so we will write pi by 6. So 2 theta plus pi by 6 equal to pi by 6. Both are pi by 6, cancel out. 2 theta equal to 0. So theta equal to 0 divided by 2, which is 0 degrees. This is our first answer. In fourth quadrant, this one, again cos is positive. So we will write second answer here, which will be 2 theta plus pi by 6. And we continue from here. This time we'll write minus pi by 6. In this direction, this will be minus pi by 6. So 2 theta becomes negative pi by 6 minus pi by 6. 2 theta is negative pi by 3. If we add them, it becomes 2 pi by 6, okay, which is pi by 3. Let's keep it like this and continue here. Now the theta will be now negative 2 pi by 6 divided by 2. When we divide by 2, we multiply the denominator. So 2 and 2 can cancel out. So theta is minus pi by 6. This is our second answer. Let's go to negative. So we know that cos is negative in this direction. Okay. Let's see if that after manipulating with this, it gives us some answer or not. So this angle is going to be pi by 6, right? Because negative square root 3 over 2 will be pi by 6 from pi, from here. So I can write here that 2 theta plus pi by 6 will be how much? This will be pi minus pi by 6, because our calculations start from here. Keep in mind, this is the angle I'm talking about, from 0. This is pi by 6, so pi minus pi by 6 will give us this answer. So pi minus pi by 6 will be, may give us an answer, may not give an answer. Let's see what happens. So 2 theta equal to pi minus pi by 6 minus pi by 6. So 2 theta equal to pi minus pi by 3, yeah, which is 2 theta equal to 2 pi by 3. We can cancel 2 and 2, and yes, theta equal to pi by 3 is also in this domain they have given us. So this is the third answer. So we got 1, 2 and 3 answers for this. Let's move on to question number 6. The polynomial, this ax cube plus bx square plus cx minus 5, where a, b, c are integers, given that the differentiation of polynomial px when x is 0 is 12. So we have to differentiate first. We will go further later. First we will differentiate and see what it gives us. So what is the differentiation of ax cube? Is 3 comes in front, ax, and 3 goes down by 1 square, plus 2 comes in front, 2bx, and goes down by 1, which is 1, plus c. This is the differentiation of p prime x. Now they said that p prime 0 is 3a 0 square, yeah, plus 2b0 plus c, which is equal to 12. This is what we got from this line. This is 0, so gone, 0 multiplied gone, so c is equal to 12. We got c. Okay. What else they have given? It is also given that px has a factor 3x minus 1. So when factor is 0, one of the constituents of a particular multiple is 0, then whole will become 0, right? What I'm trying to say is here, 0 times 5 is 0. If one of the factors is 0, the main number will also be 0. And this is what I'm going to do here, which gives me 3x equal to 1 and x equal to 1 over 3. That means in polynomial, if I put x equal to 1 over 3, I should get a 0. And that's what I'm going to do, the ax cube. X is 1 over 3 in this case, cube, plus b 1 over 3 square, plus c 1 over 3 minus 5. And c, I can substitute c by what? I just got it 12. 12. So what do I get here? This is, there has to be 0, huh? Because it's a perfect factor of the polynomial. Okay. So it is 1 over 27. So 1 over 27a, 1 over 9b plus, yeah, 1 over 9b, and 3 and 12 can cancel. So 4 minus 5 is minus 1 is equal to 0. This is one of the equations. Let's see if we get a third equation by the third sentence. and a remainder of 95 when divided by x minus 2. So remainder theorem says that if x minus 2 is 0, we are left with the remainder. That means x is 2. That means P2 will be equal to the remainder. They have given 95 in this case. Okay. And what will the polynomial become? A 2 cube plus B 2 square plus 2C minus 5, which is equal to 95. Okay. So C is known to us now, and A and B are not. So let's see what equation it gives us. 8A plus 4B 2C. 2C is, C is 12. So 2C will be 24 minus 5, 19. So I will write 95, and because it's plus 19, it will become minus 19 to the other side. Okay, let's say what it gives us. 8A plus 4B equal to 76, and we can divide all of them by 4. To make it simple equation, as much simple as possible, always do that. So 2A plus B equal to 76 divided by 4 is 19. So it can give us B equal to 19 minus 2A, isn't it? Yes, B equal to 19 minus 2A. Now substitute this one. Substitute B equal to 19 minus 2A in equation 1, and this is my equation 1. 1 over 27A plus 1 over 9B. B is 19 minus 2A. Okay, minus 1 equal to 0. In such equations where we have some denominators, see what is the LCM of the denominators. 27 and 9, the LCM is 27. So we'll multiply the whole equation by 27 so that we get rid of them. So 27 multiplied by 1 over 27 is 1. So we are left with just A. 27 multiplied by 1 over 9 is 3 plus 3. 19 minus 2A minus 27 equal to 0. 27 times 1 is also 27, okay? So let's open the bracket. I'll continue. A plus 57 minus 6A minus 27 equal to 0. A minus 6A is minus 5A. And let's bring them here. It becomes 27 positive minus 57. Minus 5A equal to minus 30. A becomes minus 30 divided by minus 5, 6. So we got earlier C equal to 12. Now we got A equal to 6. And now we can get B by this relationship. We knew this. Let's find it here. B equal to 19 minus 2 times A is 6 now. So 19 minus 12 is 7. So B becomes 7. This becomes our final answer. A is 6, B is 7, C is 12. B part. Show that equation Px equal to 0 has only one real root, and that real root is, they've already given 1/3, isn't it? They said 3x minus 1 divides it completely. That means that is the only root. That's others. What they mean is the remaining part does not have any root. So what is the remaining part? So 3x minus 1, we can divide the whole polynomial by 3x minus 1 and we'll get the rest of it. So what was the polynomial? It was this one. A we got now 6. So 6a cube. 6x cube rather, sorry. 6x cube. B is 7. 7 positive, yes. Plus 7x square. C is also positive. 12x minus 5. Let's divide. So 3x, I need 2x square to make it 6x cube. So 2x square, 6x cube. 2x square times minus 1 also we have to complete. So minus 2x square will be here. So this becomes negative, this becomes positive while subtracting. So it becomes 9x square. plus 12x minus 5. 3x becomes 9x square when I multiply it with plus 3x square. 3x only, sorry, 3x. 9x square and minus 1 times 3x minus 3x. This becomes negative, this becomes positive, this cancels, this becomes 15x minus 5. Okay, and we can see that if I multiply by 5, 3x will become 15x. So 15x minus 5 are completely divided. But this was already known to us, yeah, that it will completely divide it. But what we need to prove that this has no real roots now. That 1 over 3 is the only real root. So what will we see? We have to prove that we need to show that 2x square 1 plus 3x plus 5 doesn't have real roots. And how do we show that? For that, the b square minus 4ac, the discriminant, has to be less than 0. If it is the case, it has no real roots. So b, let me show what is a, what is b in this. So this is a, this is b, and this is c. So b square minus 4 times a c should be less than 0. So 9 minus 8 times 5, 40 is less than 0, minus 31 is less than 0, which is true, and that's why it's proven that this doesn't have real roots, and 1 over 3rd is the only root this polynomial has. Shall we go further? Question number 7. Okay. A 6-digit number is to be formed using the digits this. Okay, 6-digit 1, 2, 3, 4, 5, 6. So rather we have more. 7. Okay, 6-digit only, no? But candidates are more. So 1, 2, 3, 4, 5, 6 spaces, but we have to fill with 10 digits. I hope there is nothing is missing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of them. Nothing is missing. Sometimes they trick you by, skipping some number. Each digit can be used only once in any 6-digit number. A 6-digit number cannot start with 0, of course. Alright. So, let's start with the first digit itself. If we have 10 candidates, how many can come in first one? 9. Okay. And we'll multiply the number of options after that. The second digit, how many can come here? Now 0 can also come. But one of the previous 9 have been used. That one cannot come here because they said it can be used only once. That means out of the 10, all of 10, 1 was used here, so 9 are remaining here. So this 9 is because 0 is not there. This 9 because one of the numbers has been already used. And now we will reduce them by 1 every time and we'll get our answer. 30, 210, 16, 80. Times 81. For this I'll need calculator. By the time I do this, I would request you to like this video, give it a thumbs up, share with your friends. I think this is the first video on internet which has the solution of this particular exam, and subscribe to Math United. What I'm getting here is 136080. Okay. Next question. How many of these 6 digits numbers are divisible by 5? For being divisible by 5, we need to have 0 or 5 as the last digit. But the problem is that 0 cannot be here as well. So the 0 is common between these two conditions. So what will I do? I will just write two different conditions for 0 and 5. So I'm writing for 5, I'm writing here. For 0, let me write here. Okay. So if 5 is used here, that is the only one number I can have in this sequence. Okay. Now I'll start from here. 5 is already used, so it is out of bounds for usage now. Remaining a 9. Out of 9, I can't use 0 in the first one. So I'll use 8 here. Now, One number has been used here, one number has been used here. Now numbers including 0 can be used here, are remaining 8 again. By the same logic, why we have 9 here. And then it will be times 7 times 6 times 5. Okay. Now for 0. 0 is used. 0 is the only candidate here, 1. And 0 is not used here because it has been used here. Anyway, it is not used here. So 9 will be the candidates for this one. 0 is out of bounds and it is not being used as 9 of them. So 1 is used here, one of the remaining 9 numbers used here. So total remaining here is 8, then 7, then 6, and then 5 times 1. Let's see what we get here. Will be 13440, and this one, it will be 30, 210, 1680 times 9 will be 15,120. And we need to add these because both cases were separated. Now we have to combine them. It will be how much? 0, 6, 5, 8, 2, 28,560 numbers out of 136,080 will be divisible by 5. Okay. B. A committee of 7 people is chosen from 6 doctors, 10 nurses, and 8 dentists. Okay. So doctors, nurses, and dentists. 6, 10, and 8. Okay. Find the number of committees that can be chosen. So committee of 7 is to be chosen from how many? 6 plus 10 is 16, 16 plus 8, 24. So it will be 24 C, how many? 7. 24 C 7. I will evaluate this later when I will use my calculator. Let's go to second part. Find the number of committees that can be chosen if all the doctors have to be on the committee. All the doctors, that means 6 doctors and only 1. So 6 doctors are completely there. So what is left? The 7th person is to be chosen basically. So 1 person is needed from the remaining 18 people. And 18C1 is 18. That's the 18 is the answer. No need to use calculator for this one. Find the number of committees that can be chosen if there has to be at least 1 dentist on the committee. Okay. We need to have 1 dentist at least. They said at least, right? At least. Can we have all of them? Yes. So they said at least 1 dentist on the committee. That means we can have all of them dentists as well. So dentist is at least 1, 2, 3, 4, 5, 6, 7, all of them. Rest we will write then nurses and doctors. Don't you think it is too much of calculation? Let's look at a case that there is no dentist. Yeah. And every member, all 7 members are either nurses or doctors. And subtract that from this big number we'll get here. That will give us all of these situations because out of this list 0 is the only one missing. That's what we'll find out and subtract from 24C7. So 24C7 minus a dentist, if removed, there are 16 of them. So we need 16C7. All of them either doctors or nurses. This is the number of combination. We'll subtract and we'll get the case they're asking for, that at least 1 dentist should be on the committee. Let me use my calculator again. And again, I will ask you to subscribe to my channel to motivate me to make many more videos like this. What I'm getting here is 346104. And I have to subtract 16C7 from this, which is 334664. 334,664 ways at least 1 dentist will be there in the committee. Okay. Next question is question number 8. I think this is question number 7. I've not numbered them. So yes, question number 8. which I've not. I hope you're aware why I am preparing these questions myself, not copying what Cambridge gives because of the copyright issues. I am doing it myself. I'm doing this hard work for you. Okay. It is given that f is a function. There is no role of this here. Okay, 3x plus 1 square. So let me write it here. Fx is 3x plus 1 square minus 4. Okay. For that x is greater than or equal to a. Equal to is also there. And that f inverse exists. Find the least possible value of a. Okay. So we can see that this is the vertex form. If I try to draw its graph, we can see that it's positive. That means opening up, and its vertex will be this divided by the coefficient of x, which is 1 over 3. Positive, no, negative 1 over 3, because the sign is positive here. So negative 1 over 3, let's say negative 1 over 3 is here, and negative 4 also. So negative 4 will be somewhere here. So this is the vertex, and this is the graph. This is how it will look like. Okay, but they have given a sentence that x is greater than a such that the inverse of f exists. In this case, inverse does not exist because if I draw a horizontal line, it crosses at two places. If I find its inverse, that will cross vertically at two places, which is not a requirement for a function. So what should I do? I should erase half of this so that x is greater than some number. Where is it greater? It is here greater or here? Which way it is greater? If I say this is the a part, because they are saying the least, yeah, they have not said least, but it is because less than x, so this will be the part. That means x has to be greater, this one, not the lesser than a part. So I will erase that one to make it a function such that its inverse exists. So this is the one, and now they're saying write down what is the possible value of a, least, and we got it. It is minus 1/3. X, least possible value of this is minus 1/3 is the least value. Okay, using this value of a, write down the range of f, and this y value we already know, which is -4. So range becomes fx is greater than or equal to -4. Using this value of a, again sketch the graph of y equal to fx, and this on the axis stating the intercepts with the coordinates of axis. Okay, so I already have the graph, by the way. So I can say that y equal to fx is pretty much with me. I just need to reflect it on y equal to x. Oh, this is needed. This, they said intercepts, stating the intercept. So I will find this intercept. For this intercept, x axis, this is x axis, right? Y has to be equal to 0. That means I will make this fx equal to 0. I'll get the x intercept. So 0 equal to 3x plus 1 square minus 4. 4 goes to the other side, becomes positive, equal to 3x plus 1 square. I'll square root both sides. So it comes plus minus 2 equal to 3x plus 1. I'll be interested in that number which will give me a positive number, because the negative number I have already erased. So in -1 I will erase. If I bring this one here, it becomes 1 plus minus 2 equal to 3x. What will give me positive? Positive will be given by positive. That means I have to ignore the negative. So let me erase the negative based on my requirement. Okay, it's gone. So I will just find out now that 1 plus 2 is 3 equal to 3x. So x is equal to 1. This is 1. The x intercept is 1. Y-intercept, we don't know. So let's find y-intercept also. For y-intercept, x will be substituted by 0 here in this one. So y equal to 3 times 0 plus 1 square minus 4. So y equal to, this is 0. So 1 square is 1, 1 minus 4, which is minus 3. So my y-intercept is all known to me, minus 3. The main part is remaining now that we have to sketch the inverse, graph of the inverse as well. And let me do it here. Because inverse is always the reflection of the main graph on y equal to x line, this line. So I can see that the image of this point is itself. Image of this arrow will be in this direction. Image of 1 will be 1 here. Let's say here. Okay, then minus 3 will be the minus 3 on x-axis. So if there is 1, minus 3 will be somewhere here. And let's join that. And this will be minus 4. This will be minus 3. This will be positive 1. So all the intercepts and all the shapes have been shown here. This is the graph of f inverse x. This was the graph of fx. Clearly show it in your graph and you will get it. Okay. B, it is given that gx, another function is natural log of 2x square plus 5 for this. hx equal to 3x minus 2. There is one more for x is greater than 0. Both of them are positive. Can you see? X is greater than 0 means positive. Solve the equation hgx equal to 4. Okay, so it has nothing to do with the first part, so we can hide it now. Okay, so hgx, this is what we need to know. It is equal to 4. That means inside parent function h, input gx. So h is here. In place of this x, we will write gx, the whole value of it. So here I will write hgx will be equal to 3 times ln 2x square plus 5 ln 2x square plus 5. That's it. Okay. Minus 2 was also there. So minus 2 is equal to 4. Okay. So first let's get rid of this minus 2. So it will be 3 and 3 also. Let me not write 3 here. 3 can become exponent of this. So natural log of 2x square plus 5 cubed is equal to 4 plus 2. And if I want to find the value of x, because they're saying solve the equation, so I have to get rid of ln. So when we remove ln, so 2x square plus 5 cube x cube is removed. So after removing natural log, the other side becomes e to the power. It becomes e to the power 6. 4 plus 2 is 6 and e to the power 6. Now we want a cube root of both sides. So let's do it here only. Cube root, so that we get rid of cube here. So we are left with just 2x square plus 5 equal to cube root of e to the power 6 will be e square. So 2x square equal to e square minus 5, x square equal to e square minus 5 over 2. And if I square root, in square root we write plus and minus both. X is equal to plus or minus e square minus 5 over 2. However, here they have given x is greater than 0, That means it has to be positive. So since it has to be positive, we will ignore negative and write here negative ignored, as x is greater than equal to 0. It has to be positive, so positive. Don't even write positive, that's also fine. So let me erase that one also. That's the final answer we have. Moving on. Question number 9. Okay. Question number 9 says, solve the equation this one. For x is greater than 0, give your answer. That means x is also 0 or positive. According to this, give your answer correct to 1 decimal place. Such questions are not troublesome if you simplify them by assuming something. So one is 2 over 3, one is minus 2 over 3 exponent. So let me assume that x to the power 2 over 3 is t. Okay, so what does this become? It becomes 12t. This one, right? Now x to the power minus 3, if I reciprocate this one, it becomes x 1 over x to the power 2/3, and this becomes 1 over t. Yes or no? And x to the power 1 over x to the power 2/3 is what? X to the power minus 2/3 is the same thing. So I can write minus 5 over t, the second one, this part. Then we have minus 11 equal to 0. And now we'll solve it. And first we'll substitute, multiply rather the whole equation by t, so that this t is taken care of. So t times 12t, 12t square minus 5 only, minus 11t equal to 0, because this t got cancelled with this and t multiplied with 11. So our quadratic equation now is 12t square minus 11t minus 5 equal to 0. Now how do we get, can I split the middle term? So 12 times 5 is 60, and 60 is also 15 times 4. So we can write 12t square minus 15t plus 4t minus 5 equal to 0. Okay, so can take 3 common here, 3t, 4t minus 5 minus 1, no, plus 1. 4t minus 5 equal to 0. So the first factor becomes this, and second factor becomes this. So we'll separate them now. This one will be 3t plus 1 maybe equal to 0, and 4t minus 5 equal to 0. This gives me 3t equal to minus 1, t equal to minus 1/3. And t was assumed to be this. So I will write x to the power 2/3 equal to minus 1/3. To get rid of 2/3, I'll give both of them an exponent of 3 over 2. Okay, and see if I get a solution. Secondly, here 4t equal to 5, so t becomes 5 over 4. So x to the power 2/3 is 5 over 4, and I'll give again 3 over 2 to both sides and see what answer it gives me. It cancels here, it cancels here. So x equal to, let me use my calculator for both, and by the time I do this, I request you to like this video, give it a thumbs up, and subscribe to Math United. That will motivate me to make many more videos in future based on this topic as well. I think I'm the first person in the world to make this solution video for YouTube. This came out to be 1.39754 dot dot, which we can round off to 3 significant figures. So 1.40 1.40 is the solution of this, x equal to, and this has a square root. Because of this negative, there can't be a square root, not possible, so invalid answer. We don't get any answer from this. In this question, all lengths are in centimeter and all angles are in radians. Okay, the diagram shows a badge which consists of a minor sector. Okay, this is the minor sector, OAB, and of the circle center O. That means this 12, this is also 12. Okay, if this is the center. Okay, and a kite, this is a kite. Okay, OBCD, OB is equal to OD, so this is also 12. And CD equal to CB, CD equal to CB. The arc AB has length 27. Okay, they have given already. The line OB is perpendicular to the line CB. Okay. And COA is a straight line. COA is a straight line. Okay. Find the perimeter of the badge. So perimeter, we already know 12. We already know 12. We already know 27. The only challenge here is to find this length DC or CD and CB. These two lengths, if we know, we can find the perimeter of the badge. So if somehow I know this angle, I'll be able to find side CB, and CD is equal to CB, so there will be no problem. So let's call this angle as alpha. And this angle alpha can be found with the help of angle theta, right? We know that the arc length is equal to radius multiplied by theta. That means theta will be arc length divided by r, right? So we know it. What is arc? 27. What is r? R is 12. So that comes out to be 2.25 radians. Now we need alpha, and alpha will be, this whole line is a 180-degree straight angle, which is pi in radians, minus theta. Theta is 2.25. That is alpha. Okay. So now we know alpha also. This is the value alpha, which is pi minus 2.25. And with the help of this, I can find the side CB now, because this CB is opposite to alpha and this is adjacent, right? This 12, this radius. So I can write that tan pi minus 2.25 is equal to opposite, which is unknown, CB over 12. So that means CB, which is also equal to CD, which is equal to 12 times tan pi minus 2.25. Just put this in a calculator and we'll get it. By the time I do this, I would request you to like this video, share with your friends, and subscribe to Math United to motivate me many more videos like this in future. Okay, so I'm getting here is 14.8635. Let me use all of them. 14.8635. And now we can find perimeter because we know everything else. So 2 times 14.8635, that's this side plus this side. Then we'll have 12, 12 and 27 extra. 12 plus 12 plus 27. So 24 plus 27 is 51 plus this. So times 2 and plus 51. It comes out to be 80.727. So I can write 80.7 is the perimeter. What next? I have to write unit also, or in centimeters, right? So we can write this as centimeter. Okay. Find the area of the badge. All right. So we'll have to find the area. Let's plan how to find area. Okay. So I'll find the area of this triangle, which is right angle triangle. I know this side. I know this side. So one will become height. One will become base. I know this. I know this. The same length. That means these two are congruent angles, triangles. I will find the area of one. I'll multiply by 2. Only thing I need to add is the area of the sector. So area of badge equal to 2 times area of triangles plus area of sector. That's it. Okay. So let me write here. 2 times area of triangle will be half base. Let me call 12 as base. And the height I got was 14.8635. I'm writing this big number because I don't want to get too off from the main answer. So this is the area of triangle and 2 times plus area of sector. Area of sector is half r square 2.25. That's the angle theta we got here, right? So I will carefully put this in my calculator, and I get 340.362, which can be rounded off to 340 centimeters square. Okay, what next? The area is found. 11. In the triangle OAB, OA is vector A. So from starting from O ending at A, the direction is very important, okay? OB is B, okay? This direction is B. The midpoint of the line OB is X, okay? This is half B and this is half B, okay? Can you see I'm interpreting every information into the drawing so that I understand it better. And the midpoint of AB is Y. AB is Y. Okay, so we know this and this line segment are equal. Okay, at Z, OY and O, okay, they intersect at Z. That's fine. It is given that AZ A and Z. Okay, this one AZ is equal to lambda AX. Okay. So this is the lambda fraction of AX, and OZ, where is it? OZ is mu fraction of OY. Okay, understood. So lambda, okay, here and mu here, but this is not the length, okay? Where lambda and mu are rational numbers, find OZ in terms of A, B and lambda. OZ, right? Whenever you want to find any vector, start from the first letter, end at the second letter by a different method so that you reach at that position. So what I will do this way. Look, I will go OA here, OA, and then I will write AZ. So I can write here OA plus AZ. Okay. So OZ can also be reached with this, that is the vector. OA is A, we already know. The problem is AZ. Since AZ is part of AX, let's find AX in terms of AB. So if I want to go from A to X, I can go to A to O first. A to O is minus A. And then from O to X is half of the B. Okay. And AZ, they have given already. If I look here, AZ is lambda AX. That means in place of AX, I can write its value in terms of A and B, and I will write the positive half B first. Okay, so AZ comes out to be lambda half B minus A. This is what I'm going to substitute here. OZ they wanted, OZ equal to OA is positive A plus lambda half B minus A I got for AZ here. So this is done, but I can, there's no need. Okay, this they wanted in terms of AB and lambda. I've done that. This is enough. If I need to open it up, I'll do it later. Now let's use the other space for part B. B says find OZ in terms of AB and mu. Same thing. Okay, mu. OZ in terms of A, B and mu. So mu is in the same direction, right? But we need OY in terms of A and B. OY. Starting from O. So how can I go to A and B? Not possible. So let's find AB first and then we can do it. AB. will be AO plus OB, right? AO is minus A and OB is B, which is B minus A, right? So AB is B minus A. This AB is B minus A. So OY can be written as OA plus AY, right? OA plus AY. So which will be OA is A and AY is half of AB. AB is from here to here and AY is half of that. So what was AB? AB was B minus A. So let's see what we get here. If I open this, I get A plus half B minus half A. A minus half A will be half A plus half B. So 1 over 2 A plus B is OY, right? And our OZ, that's what they're asking, right? OZ, they're asking, which is mu times OY, mu fraction of OY. So OZ is mu times, let's write half here, A plus B. I just multiplied this by mu and I got OZ, and that was the B part. Find OZ in terms of A, B and mu, done that. So we got OZ here, this and this both, and now I'm sure they're asking about find, yes, lambda and mu now. So we can equate the two we got here. OZ equal to A plus lambda half B minus A, which is also equal to half mu A plus B. Yeah, that's what I equated. Now we have a interesting situation here because two things are equal to, but you must notice that A is in this direction and B is in this direction, and you should know always that one vector cannot be converted to another vector by multiplying by some scalar or something. It is not possible. A vector, if multiplied, it remains in the same direction. That means we can separate A and B in these two. So if I separate A here, let me write here, A plus, and this is also A, right? But it is multiplied with lambda. So minus lambda A, that's what I can write. A minus lambda A, because this lambda multiplied with A, so minus lambda A will be equal to 1 over 2 mu A. So B is not involved at all. Only A can be converted into the direction of A by multiplying some scalar numbers, and these are real numbers, lambda and mu, so we can write that. So if I divide all of them by A, so I can get rid of A. I'll be left only with lambda and mu's. So what will that be then? 1 minus lambda, that's it, equal to half mu. This becomes an equation only with scalars. Let's compare B's. So we can write here, comparing vector A, or multiples of vector A, you can say scalar multiples. Okay. Now comparing B. So we don't have any B here. We have just this one B. So it will be half lambda B. They are multiplying. Half lambda B equal to half mu and B. They are exactly similar. That means half cancels with half. B cancels with B. Lambda is same as mu. They will have exactly same value. Okay. So let me this is equation number 2. I will substitute equation number 2 in equation number 1. So this was equation number 1. In place of this lambda, let me write mu, because both of them are equal. So 1 minus this equation number 1 minus mu now equal to half mu. 1 equal to plus mu plus half mu 1 equal to 3 over 2 mu. So cross multiply, mu equal to 2 over 3. And so is lambda. Both of them are 2/3. This is what I'm getting. Let's see, there's D part also. Hence, write OZ in terms of A and B only. OZ, we had two equations. So OZ was this. This is easier one, right? So we want to write in terms of A and B. In place of this mu, I will write its value 2/3. Half mu A plus B. Okay, so OZ was half mu A plus B. So OZ becomes now half 2/3. Yeah, that's what I got, 2/3. Here, A plus B. So 2 and 2 cancel. OZ finally comes out to be 1/3 of A plus B. Question 12. A curve has equation this. Let me write it properly here. It is square root of 5x minus 2 divided by x minus 3. Okay, that's why. Okay, explain why the curve does not exist when x is less than 2/5. So we know that for any square root to exist, we must have its value equal to or greater than 0, right? Let's see what is that range for which it exists. They're asking it does not exist, okay? But let's see for what it exists. So we will square both sides. So what we get, 5x minus 2 is greater than equal to 0. 5x is greater than equal to 2 and x is greater than equal to 2/5. So for this value, the curve exists. But if it is, let's say so, for x less than 2/5, curve does not exist. Because it will be undefined, and if it is undefined, then curve cannot exist at that particular part. Okay, let's see what next part says. Show that dy over dx can be written in the form of this. So let me see, square root 5x minus 2. So we'll have to differentiate it. Square root 5x minus 2 over x minus 3. That is the equation. So we will have to differentiate this and we'll use quotient rule. For quotient rule, we square the denominator first, then we write the same denominator and then we differentiate whatever was the numerator, which is 5x minus 2 in this case, minus, first we write the numerator as it is and then we differentiate the denominator. Okay, and hopefully when we simplify this, we'll get this format. So x minus 3 remains x minus 3. Okay, the differentiation of 5x minus 2 to the power half. Yeah, let me say 5x minus 2 to the power half, because square root is same as exponent half. So to differentiate this, half will come in front and then exponent will go down by 1. So half minus 1. And further we have to multiply by the differentiation of what was inside, which is just 5, because differentiation of 2 minus 2 is 0. Differentiation of 5x is this 5. So what do we get? 5 over 2 of 5x minus 2 to the power minus half. So now it was positive half, exponent became minus half, which is again a square root, but at the denominator. That's what I'm going to write here. 5 over 2 square root 5x minus 2. That is the differentiation of square root 5x minus 2. And then minus square root 5x2 remains, square 5x minus 2, but differentiation of x minus 3 will be just 1 because minus 3 again differentiation is 0. And then we have divided by x minus 3 square. Now we have a denominator within this thing. So let's do what? Let's multiply the whole of the numerator by 5x minus 2, rather 2 also, right, and denominator as well, so that we get rid of the denominator inside the numerator. So when this multiplies with this whole expression, this 2 square root 5x minus 2 will cancel with this one, so we'll be left with just 5 and x minus 3. This is what it is. So minus square root 5x minus 2, okay, but it is multiplying with this, so 2 will come in front and this will be squared, isn't it? This and this, because both are square root same thing, they'll be squared, but 2 will not be squared, there is no 2 here. And then this is gone, so 2 will be staying here. 2x minus 3 square root 5x minus 2 when this multiplies this. Okay, so we are very close to that one. Now let's see what happens. 5x minus 3 becomes 5x minus 15. This square and square root cancel, so 2 will multiply with straight away 5x minus 2, which is minus 10x plus 4 over 2x minus 3 square root 5x minus 2. So 5x minus 10x will be minus 5x. And minus 15 plus 4 is minus 11. Both are negative. Over 2x minus 3 square 5x minus 2. And this matches with the format they were saying, exactly like that. Can you see? So I get minus common and ax plus b. So if I take minus common here, will we get 5x plus 11 because minus is out of both, and denominator is matching there, so we don't have to worry about it. So our a is 5, b is 11. This concludes our solution video for this paper 12 IGCSE Mathematics Additional Math. I hope you liked it. If you did, give it a thumbs up, share with your friends, and subscribe to Math United. Thank you very much for your attention.